Today we are going to learn about Advanced Python JSON, handling nested data structures. We'll explore techniques for parsing, manipulating, and validating deeply nested JSON data structures, equipping you with skills to manage complex APIs and data storage solutions.
In today's interconnected digital world, JSON, or JavaScript Object Notation, has become the lingua franca of data interchange. Its lightweight and readable format makes it ideal for transmitting data between a server and a client. However, when JSON data becomes deeply nested, it can pose significant challenges in terms of accessibility and manipulation. In this session, we'll dive into the intricacies of nested JSON structures, often encountered in complex APIs and databases. Understanding these structures is crucial for anyone working in data science or software development, as it allows for efficient data manipulation and integration. This introduction sets the stage for a comprehensive exploration of techniques and tools to master nested JSON data handling in Python.
Accessing nested JSON data in Python primarily involves dictionary indexing, as JSON objects are converted to Python dictionaries. When dealing with simple one-level dictionaries, accessing values is straightforward. However, as the data becomes more nested, the complexity increases. Imagine a JSON object with several layers. Accessing the innermost data requires careful navigation through each level. Using Python's dictionary indexing, we can reach deeply nested data by chaining keys. However, this comes with the risk of encountering a key error if a key doesn't exist. To mitigate this, Python offers the get method, which allows us to provide a default value if a key is missing. In this block, we'll explore practical examples and best practices for efficiently accessing nested data, ensuring you can handle any key errors gracefully and maintain robust code. For those who often work with deeply nested JSON data, the jsonpath-ng library is an indispensable tool. JSONpath is a querying language for JSON, similar to spath for XML. It allows for sophisticated queries that can extract and filter data based on complex expressions. Unlike standard dictionary indexing, JSONpath can traverse through JSON objects dynamically, offering more flexibility and power. The jsonpath-ng library in Python implements JSONpath syntax, allowing you to perform advanced queries on nested JSON data with ease. In this segment, we'll introduce the library, delve into the syntax and expressions, and demonstrate how JSONpath can be utilized to perform complex data extraction and filtering operations. By the end, you'll be equipped to handle even the most intricate JSON structures with confidence. While JSON is excellent for data interchange, Python objects are often more suitable for data manipulation within applications. Transforming nested JSON into Python objects can bring several advantages, including type consistency and ease of manipulation. Python's data classes module provides a way to define classes that can automatically generate special methods like _init_ and _repr_. By converting JSON data into data classes, we can leverage these benefits, making our code more readable and maintainable. In this block, we'll explore how to structure nested JSON data as Python objects using data classes. We'll walk through a practical transformation process that highlights the importance of maintaining type consistency and how it can simplify data manipulation tasks. Handling deeply nested JSON structures can sometimes be daunting, especially when the depth isn't known beforehand. Recursive functions come to the rescue in such scenarios. Recursion involves a function calling itself with a subset of the original problem, making it ideal for processing tree-like structures, such as nested JSON. By applying recursion, we can traverse and manipulate JSON data of unknown depth efficiently. In this segment, we'll delve into the basics of recursion, understand how to implement it in Python, and explore practical examples of using recursive functions to manage complex nested JSON structures. This approach not only enhances code readability but also ensures robustness when dealing with intricate data.
In the world of JSON data, missing keys and optional fields are common occurrences. These can lead to errors and data integrity issues if not handled properly. One of the simplest strategies is to use Python's dictionary get method, which allows specifying a default return value if a key is missing. This prevents key errors and ensures the program continues to run smoothly. Additionally, implementing fallback mechanisms and defining default values for optional fields can greatly enhance the resilience of your code. In this block, we'll discuss these strategies in detail, emphasizing the importance of maintaining data integrity while gracefully managing missing keys and optional fields in nested JSON structures.
Before processing JSON data, validating and cleaning it is crucial to ensure quality and reliability. Data validation involves checking the data against predefined criteria, such as type, range, and format. In Python, libraries like JSON schema provide powerful tools for validating JSON data against a schema, ensuring conformity to expected structures. Besides validation, cleaning involves transforming malformed or inconsistent data into a usable format. This includes removing unwanted characters, correcting data types, and handling duplicates. This block will cover the importance of validation and cleaning, introduce tools and frameworks available in Python, and showcase practical examples to ensure your JSON data is always ready for processing.
Learning techniques for handling nested JSON data is best reinforced through practical examples. In this segment, we'll dive into real-world datasets from popular APIs, analyzing their complexity and extracting meaningful insights. These examples will highlight common challenges encountered when dealing with nested structures, such as varying data formats and optional fields. We'll apply the techniques learned throughout this video, including dictionary indexing, JSON path queries, and recursive functions, to manipulate and extract data effectively. By examining these real-world scenarios, you'll gain valuable insights and confidence in applying your skills to tackle complex JSON datasets in your projects. We've explored a wide array of techniques for handling nested JSON data structures in Python. From basic dictionary indexing to advanced JSON path queries, transforming JSON into Python objects, and managing deeply nested structures with recursion, each method equips you with tools to work efficiently with complex data. Mastering these skills is crucial for anyone dealing with APIs, data storage solutions, or any form of data manipulation in today's tech-driven world. As you continue your journey, remember that practice is key to reinforcing what you've learned. We hope this session has empowered you to tackle even the most intricate JSON challenges with confidence. Thank you for joining us.